Alright guys, so yesterday we looked at the sine graph. Today we're going to look at the cosine graph. We're going to see a lot of similarities between the two. Just to get the shape, we're going to fill in this table of points again. But as you saw with the sine graph, once we do that and get the shape, we're going to have a different method. So we're going to go quickly through I'm going to help you get these points pretty quickly. I want you to plot them to find the shape. Okay. So cosine of 0, if you know it, let me know. If not, it's okay. We could figure it out. But cosine of 0 is 1. Cosine of 30 degrees, or pi over 6, not 1. It's root 3 over 2, which is about 0.9. Cosine of 45 degrees, root 2 over 2, which is about 0.7. Cosine of 60 degrees comes out to be 1/2. And those are the only three kind of answers that come up here with sine and cosine, which is 0.5. And then cosine of 90 degrees is 0. And then we're going back into quadrant 2. And this is a 60-degree reference angle in quadrant 2, so we get back to 1/2. And then a 45-degree reference angle in quadrant 2 gives us root 2 over 2. 30-degree reference angle in quadrant 2 gives us, actually I'm making a mistake here. Correct my mistakes. These should be negative because they're cosine. And in quadrant 2, cosine is negative in quadrant 2. So these are negative root 3 over 2. And this would be negative 1. Okay. This is a repeat, negative 1. Quadrant 3. Okay, now we're in quadrant 3. Cosine positive or negative? Negative. And so this is negative root 3 over 2 for 30-degree angle. 45-degree angle in quadrant 3 gives us negative root 2 over 2. 60-degree angle in quadrant 3 gives us negative 1/2. And then negative 270. What's that? Or sorry, 270 degrees gives us what? For 0. And now we're in the fourth quadrant, so positive or negative? Positive. And so this is going to give us positive 1/2 because it's a 60-degree angle, reference angle. And then a 45-degree reference angle in quadrant 4. 30-degree reference angle in quadrant 4. And then back to our starting point. Okay. So I want you to plot those points on this graph and let's see what shape emerges. Let's see what this cosine function looks like, okay? Plot those points. All right, so we get something like this. Okay, so here's one period of that cosine function. Just like we had with the sine function, every pi over 2, every is going to give us a critical point for graphing, and so there's 5 points. I'll highlight them. So we start high at the maximum, and then we go to the equilibrium, then we go to the minimum, then we go back to the equilibrium, and then we end up with the maximum. And so this is different than the sine function, because the sine function starts at the equilibrium and then goes up to its maximum, where the cosine function, you start at the maximum and then move along. This thing continues forever as well. And by the way, if I took this off of a graph, it would look like this. And it would look no different than the sine curve. They would both look exactly the same. And in fact, they are the same curve, just one shifted over differently than the other. So the sine function would be, I'll highlight it here. Sine function would start kind of in the middle, and there's one period of our sine function, where the cosine function would start at one of the maximums and back up at the maximums. So it's just kind of where it starts and where it ends. Yeah. It's part of the same curve, but it's just shifted over differently. So if you take this, and if you start, so here's, it's where you start. So if I put my y-axis right here, and my x-axis here, then it's a sine curve. If I put my y-axis here, and my x-axis kind of as the equilibrium here, then that's the cosine. So this is the cosine curve. This is the sine curve. So it just depends where you start, but it's the same wave, is what I'm telling you guys. And so sometimes, so you can look at a wave and you can use sine or cosine to represent it because of that fact. Okay. So again, it works every pi over 2. So we're going to mark off when we create our own graphs. We're going to go by pi over 2, just like we did. Sometimes instead of pi, I'll put 2 pi over 2. Pi over 2, I'd put pi over 2. 3 pi over 2 is 3 pi over 2. Sometimes 2 pi, I'll write 4 pi over 2, just so you can see the pattern. We're counting by pi's here. Okay. And so we're going to look at some very similar questions we did yesterday. Don't want to spend too much time on this part, but let's take a look here. What's the highest value? Still 1, because it's the same curve, right? Just in a different position. But where's this happening? This is at a different location. Where's it happening? And 0 and at 2 pi in the first period of that function. Okay. Where's the lowest part? -1, and that happens where? At pi. Okay. So same max, same min, but they're happening at different locations now. This is also periodic, meaning it does the exact same pattern forever to the left and right. So domain's going to be, okay, and then the range is still going to be you go low to high. So the lowest value to the highest value, and we use the brackets, right, because it actually obtains those values. And we did this yesterday with the sine curve, so because it's the same curve we're using, we're going to have the same range. How about the, what are the locations for the function equal to 0? Pi over 2 and 3 pi over 2. Okay, so the answers that are different is what's happening on the x-axis. The y-axis is staying the same. You know, we're still hitting the same max, same min. We're hitting x-intercepts, but it's happening at different locations now on the x-axis. Amplitude, still the same definition we were working with yesterday. Cosine has an amplitude just like the sine does. Okay, and so in number 3, what's our amplitude? Right here, 1/2. Okay. Can amplitude ever be negative? No, amplitude is always positive. If there's a negative in front of that number, the negative does what? Reflects it, right? Okay. And so if I just asked you guys to graph this without, so this is wanting us to put this on that graph, and we will in a second. But if I asked you to just graph y equals 1/2 cosine x, okay, your steps to graphing this would be this. You would, again, you'd mark off on the x-axis count by pi over 2, so 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And you want to put the 5 key points on. Now, the cosine function starts at its maximum. You got to know that part. Okay, so you start as maximum, come down to the equilibrium, go to the minimum, come back to the equilibrium, back to the maximum. Almost looks like a V shape, right, with the points. It is a V shape with the points. But don't draw a V. You got to realize, okay, it's a curve going through this. So you're kind of curving down, and then curving up, and then curving that way. And then what's the maximum height of this one? 1/2. This is where the amplitude comes into effect. And the minimum would be -1/2. And so that would be how you would graph this. So you want to kind of know the general shape, how it starts and ends, and hitting those key parts. Okay. So let's compare this to the first one. Let's draw it on here. And just focus on the 5 key points. Okay. So the first point, we're going to cut that in half, put it here, and then we're going to go to the x-axis or the equilibrium, and then at pi we're going to hit a half, -1/2, so it's looking like this. And ending here. And I'll highlight it so we can follow it. Okay. And so you see the amplitude being 1/2 just keeps it closer to the middle of that graph, close to the equilibrium of that graph. Okay, so let's fill in some blanks here about this problem. What's the highest value? 1/2 happens at 0 and 2 pi. Remember, it's maximum and it starts with its maximum and ends with its maximum. Lowest value, -1/2, happens at pi. Domain is everything. Range goes from minimum to maximum. What locations is the value equal to 0? And new question here, what's the amplitude? Just +1/2, okay? Yeah. Two minimums and one max, yeah, exactly. Numbering's off a little bit here, isn't it? So we'll just ignore that part. But now number 5. Okay. So here we have the 3, which tells us what? That's the amplitude, right? And then this plus 1 moves the whole graph which way? Up 1. So this is going to become our new equilibrium. Okay? So the center of our graph now is at 1. So put the 5 key points on the graph. All right, where's the first point going to start? 0, and what height? 4. Okay. 4 because the amplitude is 3. And the center's at 1, so I need to go above the center, above that equilibrium 3. So if I'm already at 1, I need to count up 3 more. And so our first point starts at the maximum at 4. Our second point goes down to the equilibrium, so above pi over 2 at height 1. And then at 2 pi over 2, where do I go? What height? -2. And then back up to the equilibrium, and then back up to the maximum. It looks like a V shape, right? If it looks like a V shape, you know you're doing it right with the cosine. But don't draw a V, draw a curve through it, okay? And those are the 5 key points, okay? If you extend this, right, it continues with this kind of up and down pattern here. Okay. So what's the highest value for the y-coordinate? 4. And this happens at what? 0 and 2 pi. Lowest value is at -2, and that happens at pi. What's the amplitude? All right, last one. Here we have a negative. Negative reflects. So we're going to flip this thing upside down. The 2 is telling us what the amplitude is. And then this minus pi over 2 tells us what? You start, and you're going which way? To the right. Okay. So again, put the 5 key points on here. going to be upside down V, right? When you put those 5 points on, it's going to look like an upside down V. You go right pi over 2, which in our, this is marked by pi over 2 because that's pi. This would be pi over 2. This is 2 pi over 2, 3 pi over 2, and so on. So you guys have this V shape here, and here's the curve. Okay. If we continue this curve in each direction, looks something like this. Okay. And highest value is going to be what? 2 happening at? Happens at 3 pi over 2. And you said pi over 2? That's the minimum, right? Okay. Lowest value is -2, and that happens at pi over 2. And where else? In that first period, guys, where's the other 5 pi over 2? Okay, what's the amplitude of this thing? 2, or is it -2? 2. Okay, it's always positive. Right. So a lot like the sine curve, okay? There's only 2 curves that you need to know in this unit, the sine and cosine. Tangent does, but we're not studying that one, okay? So there you have it.